In this video, we're going to learn how to work integration by the method of U-substitution. So let us say you are given this question. If you are given this expression and were asked to integrate it, the method that you are going to use is the method of U-substitution. So the first thing I'm going to do, I would actually take x squared and make it to be as u. Now that is actually because I want to make this to be differentiated in such a form that we would have the power of 2 to be reduced from 2 to 1. And that basically happens because you have this having a power 1 higher than the other term right there. So u will be equal to x squared. Now if I wanted to differentiate u with respect to x, that is going to be 2x. So I'm just going to use up dx and multiply through with it. So that is going to be 2x dx. Next up, I'm going to change the position of 2x so that I will just have dx left on the right hand side. And that is because we have a dx here. I want to use that to substitute into the expression. So this is going to be dx. And we would have du divided by 2x. So that is basically what I have there. So these two forms, I'm actually going to use it and plug them back into the expression given here. So this is going to be x sine x squared. Now x squared has been replaced as u, so we're just going to write a u there. And we have a dx. So this is dx. dx is going to be written as a du divided by 2x. So actually I can take x here and have it cancel this other one. Excuse me. So I'm going to have a integral 1 over 2 multiplied by sine u du right there. Now I have 1 over 2, which is the coefficient of sine u. Now basically, as long as you have this being a constant, you don't actually need to integrate it rather, because you have it as a non-variable function. So I'm going to take it out. So this is what we have. So I just need to find out what will be the integral of sine u. Now the integral of sine u is actually going to be negative cosine u. So that is going to be negative cosine u. And I'm going to add a c on it. Now we already know that u, that is equal to x squared. So I just need to replace this u with x squared. So that gives us negative 1 over 2 cos u plus c. That will be the answer to the question. Now let us try out some more. So let us say you are given this one. What do I have to do over here? Should I take x to the third or x to the fourth? I'll make it as what? So obviously, you know, we're actually dealing with u-substitution here. So we want to make x to the fourth as u. And that is basically because we have it as a higher power as compared to x cubed. So next up, I need to differentiate u with respect to x. So that is going to be du dx. And here we're going to have a 4x cubed. So du will be equal to 4x cubed dx, right? Next up, I need to make dx to be the subject so that I would actually use the form of it to integrate. I would actually use that to substitute into dx, right? So that is going to give me du over 4x cubed. That is equal to dx, right? So we are going to have integral x cubed e to the u, because we have actually made x to the fourth as u, and du has been replaced with du 4x to the third. So we know that x to the third will cancel out. So what should we have here? This should be 1 over 4 e to the u multiplied by du. So this will be 1 over 4 integral e to the u du. Now the integral of e to the u is basically still going to be e to the u. So this is going to be 1 over 4 e to the u plus c. But we know what e to the u is. That has been given as x to the fourth. So this should be 1 over 4 e to the x to the fourth plus c. That will be the answer to this question. Now try this one. What is going to be the integral of this expression? What do we have to do in this place? So the first thing I'm going to do, I will make u to be the whole of the function which is within these brackets. And that is actually reasonable because we would actually have an x squared here, and that is one power higher than the other x which is here. Basically, this is going to be u raised to the power of 3 if I made this linear function to be as u. So that is just what I'm going to do. Now we're going to have du dx to be 2x. So we're going to have du to be 2x dx. And dx will be equal to du divided by 2x. So this form and this, I'm actually going to use it to plug back into the original expression. So this should be integral 4x, and here now we have a u, which will be raised to the third. And dx has been changed to du divided by 2x. Now obviously 2x can get cancelled with a 4x, and that would actually leave us with a 2 over here. So basically what we have left is 2 multiplied by u to the third du right there. So this would actually change and be expressed as 2 integral u to the third du. So we need to solve this. Now that is going to be u to the third plus 1 divided by 3 plus 1. I'm just going to add a c there. Now 3 plus 1 should give us 4. So this is going to be 2u to the fourth divided by 4 plus c. Now we know that 2 into 4, that's going to be 2 times. So this should be something around 1 over 2 u to the fourth plus c. Next up, we need to replace u with exactly what we know it to be. So that is actually x squared plus 5. So the answer, that is going to be 1 over 2, and we have x squared plus 5, which will be to the fourth. and this is going to be plus c. So this is actually the answer to the question. Try out this one by yourself. How can you solve this? So the first thing I'm going to do, I would actually make the whole stuff here to be as u. So that is going to be u, and this will be equal to 2 plus x to the 4th. So next up, I need to differentiate it with respect to x. And that is going to be the differential of 2. That is going to be 0. And the derivative of x to the 4th should be 4x to the 3rd. So du is going to be 4x to the 3rd multiplied by dx. Now lastly, I'm going to make dx a subject. So that is going to be du divided by 4x to the 3rd. Now, as usual, I need to replace everything back into the original function. So we have x to the 3rd divided by this whole stuff, which has been changed to u. And dx has been changed to du divided by 4x to the 3rd. So this is du divided by 4x to the 3rd. Now this is actually deliberate so that we would have the same power of function as the initial term or function in this expression. That is easy, as it's possible to get them cancelled out and leave us with just one variable here, which is u. Now we have a 1 over 4 here, so we need to take it out. That is going to be 1 over 4, and this will be integral 1 over u du. Now the integral of 1 over u should be ln u plus c. Now we know what u is, right? So u is 2 plus x to the 4th. So this is going to be ln with an absolute of 2 plus x to the 4th plus c. That is the answer to that question. Here is another one for you. So let us say you are given this expression. What is going to be the integral of this? So the first thing we need to do, we actually need to change the form that is represented here into something that would actually look a bit better, that will lead us to the answer for the integral. So first off, I'm going to change this, and we're going to have root x on top, and here we're going to have 1 minus root x cubed, right? Now this is going to be integral x raised to the power of 1 over 2, and this will be divided by the square root of 1 minus x raised to the power of 3, and of course this should also be powered to the power of half, right? Now here we can actually have 3 multiplied by half, and so that is going to give us something like this. This will be x to the half, that will be divided by 1 minus x raised to the power of 3 halves dx. So this is actually the form that we have, and this is what we need to deal with. So I'm going to wipe these out and rewrite the proper thing that we should actually have there. So this is integral x to the 1 over 2. This is divided by square root of 1 minus x to the 3/2 of dx right there. So we're going to make u to be equal to 1 minus x to the 3/2. So we need to differentiate it. Now the derivative of 1 is practically 0. So we're going to have negative of this, right? So that is minus x raised to the power of 3/2 minus 1. And that should be multiplied by 3/2, right? So this is going to be negative 3 over 2 multiplied by x raised to the power of half. That is basically what we have. Now remember, that is actually du, and if I took dx to the other side, this should give us a negative 3 over 2 multiplied by x to the half multiplied by dx. Now obviously you know that 3/2 minus 1 should actually give us x to the half, right? So that is what I'm going to use to substitute. So we have x to the power of half, and here we have the square root of u, right? Now dx has been changed to the whole stuff. So this is going to be negative 3 over 2 multiplied, whoa, I seem not to have been done with this part yet, because we actually need to reciprocate or substitute dx with what we have here in terms of du, right? So that should be a du. So du is going to be, rather dx is going to be du divided by this stuff. So that is negative 3/2, and you have x raised to the power of 1 over 2, right? So that is what you have right there. So I'm just going to replace that. Here we have du, and this is divided by negative 3/2 multiplied by x to the power of a half. So this can cancel this out. So we're going to have integral 1 over u to the power of half, because that is actually the form of the third. And here we have 2 du divided by negative 3, right? That is basically what happens. This is actually the denominator of this fraction. So you basically take it to the top part of the major fraction. So that gives you negative 2 divided by 3. Now I need to take this stuff out of the expression. So this is going to be negative 2/3. And we have 1 over u raised to the power of half. And you have du right there, right? Now we know that this could be rewritten as a negative 2/3 of integral u raised to the power of negative 1 over 2 du, right? So we need to work this by the method of integration. So that is going to be minus 2 over 3. This will be integral u raised to the power, whoa, I need to wipe this out. So this is u to the power of negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1 plus c. Now if you have negative half plus 1, what is that going to give? So that should actually give us a half. So we're going to have something like this. U to the power of half divided by half plus c, right? Now as we did in the previous step, or in the last step that I just wiped out, you actually need to take 2 and take it to the top part of the major fraction. So that is going to be 2 on top there. So we should have something like this, negative 2/3. And here we should have a 2 multiplied by u to the power of half divided by 1 plus c. Now we're going to have negative 2 multiplied by 2. That gives us a negative 4. So this will be negative 4 divided by 3, and this will be u raised to the power of 1 over 2 plus c. Now we know that this could actually be rewritten. This stuff, it could actually be rewritten as this. Square root of u plus c. Now we know what u is, right? U has been said to be 1 minus x raised to the power of 3/2. So this is going to be negative 4/3. And we would have a square root of 1 minus x to the power of 3/2 plus c. So this is actually the answer to the question. Pretty long, isn't it? Yeah. So let us try out some few more. So let's say you are given x with this dx. How can you do it? So that is actually going to be, u would actually be 3x plus 2. And so we need to do this stuff, but there is actually some little bit of change here. We can see that here, there is actually the similar power of x as we have under the square root sign. So what are we going to do? So we need to change this and make it to be in form of u. So first off, I'm going to differentiate this. This is going to be du, and here we would have a 3 dx. And so we have dx to be du divided by 3, right? Next up, from here, I'm going to make x to be the subject. So this is going to be u minus 2 is equal to 3x. So x should actually be u minus 2 divided by 3, which changes into this form. So x is going to be u divided by 3 minus 2/3. So that is actually what we have. So let us bring it back. This is going to be integral. Now we have u divided by 3 minus 2/3. And we need to multiply it by the square root of u. And here we have du to be, well, we have dx rather, to be du divided by 3, right? So this is going to be u over 3 minus 2 over 3. And this is actually multiplied by u to the power of half. And here we have 1 over 3 du. Obviously, this is actually a coefficient, so we actually need to take it outside of the integral sign. But for these ones, we need to use u to the half and FOIL them. So here we're going to have 1 over 3. This will be integral. So first off, I need to take u and multiply it with this. Next, I need to use it and multiply it with this, right? So that is going to be u over 3 multiplied by u raised to the power of half. And that will be minus 2/3 multiplied by u to the power of half. And then we have du right there. So that is actually what we have. Now, if I took this and multiplied it with this, you know that this is actually raised to the power of 1. This is raised to the power of 1. So we would actually have 1 plus half, which gives us 3/2. And over here, I just have a u to the half, so that would typically remain there. So you should have something like this. So this is going to be u to the 3 halves over 3. And here we have negative 2 u to the half divided by 3. This is du. So that is basically what we need to work. So let us do that now. Now this is going to be 1 over 3. And here we have u to the 3 over 2 plus 1, which will be divided by 3 over 2 plus 1. Now take note, there is actually a 1 over 3 that was multiplied in this case. Now here you saw a 3, right? So we need to add that, and that was basically below. So that is going to be a 1 over 3. Then here we also need to integrate this. So this is going to be a 2 over 3, and we should have a u raised to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1, right? So that is actually what we should have right there. Now that should actually have a plus c, but because of space, we're just going to write it under here. Well, I might well just write it here, c there. So this is going to be 1 over 3. And here we would have 3 halves plus 1. Now 3 halves plus 1 should give us 5 over 2. So that is going to be u to the 5 divided by 2. Here also we're going to have 5 divided by 2. And this should be multiplied by 1 over 3, right? Now over here we have 2 over 3, and we're going to have it multiplied by u raised to the power of 3 halves. And of course, should also be divided by 3 halves. And there is a plus c over there. Now, what do we need to do? As you can see, we always took this part and took it to the upper part of the fraction. So we're going to do that with this one also. So that should become 1 over 3, 2 over 5, and that is into 1 over 3 because of this, right? And this will be multiplied by u raised to the power of 5 over 2. This is minus, you got 2 over 3 multiplied by another 2 over 3. That is this 2 going up, and then here we have u raised to the power of 3 halves. And this is plus c. Right there. So what is that going to give us? Now here we have 1 multiplied by 2 multiplied by 1, which gives us a 2. And here we have 3 multiplied by 3, which is a 9. And 9 multiplied by 5, that gives us 45. So this is going to be 2 divided by 45. And that will be multiplied by u to the 5 over 2. Now here we have 4 over 9, right? So that is going to be a 4 over 9. And we're going to have u raised to the power of 3 over 2. And the plus c. Now what is the last step that we need to take? We actually need to replace u. Well, I need to take that back. We need to replace u with exactly what it was from the beginning, which is actually 3x plus 2. So that is going to be 2 over 45. And this is multiplied by 3x plus 2, which is now raised to the power of 5 over 2. And this is minus 4 over 9 multiplied by 3x plus 2 raised to the power of 3 halves plus c. So that will be the answer to the question. Now notice it's actually possible for us to factor out 2 over 9 from these two coefficients. But that is basically needless, so you might well just stop at this point. Now here is another one for you. Integral tan theta d theta. What should be the integral of this expression? How can we solve it? So the best thing you need to do, you actually need to change this into the other form. Now we know that tan theta is the same thing as sine theta divided by cosine theta. So if I replace that, we're going to have integral sine theta divided by cosine theta d theta. So this is actually what I'm going to use. So first off, let us make u to be cos theta. So that is going to be du, and du obviously should be negative sine theta d theta. As you can see, we already have that over here. This is sine theta d theta. Now what I just need to do here, I just need to take up the negative to the other side. So that should give us something like this. Minus du is equal to sine theta d theta, right? So that gives us something like this. Integral. So sine theta d theta has been changed to negative du, so I just need to write that there. And over here we have a u, right? So this could be rewritten as negative 1 integral 1 over u du, basically. Now we know that the integral of 1 over u is actually going to be ln u. So this is negative 1 multiplied by ln u, right? Plus c. Now u has been written as a cosine theta, so that should be resupplied there. I'll be rewritten there. So this should be the answer to the question. Now next up, we have this one. Integral secant theta d theta. How can you find the integral of this? So this is actually what I'm going to use. I would actually use this form, secant theta plus tan theta divided by secant theta plus tan theta. Now you know that this is actually equal to 1, right? So if I multiply this by 1, that is the same thing as multiplying it by this fraction. So that is going to be integral secant theta multiplied by secant theta plus tan theta divided by secant theta plus tan theta. And we have d theta right there. This is what we have. Now next up, I'm going to use secant theta and multiply it into this as well as this. So that is going to give us integral secant squared theta plus secant theta tan theta, right? And this is actually divided by secant theta plus tan theta. Now bear in mind that this should be multiplied with a d theta, right? Now what is the next thing that I need to do? I can actually take secant theta with tan theta and make it to be as u. So let u be equal to secant theta plus tan theta. So therefore, du will be the derivative of all this, which is c. So that is going to be du d theta. The derivative of secant is actually going to be secant theta tan theta. And the derivative of this is actually going to be secant squared theta, right? Now it happens to be that I can actually take d theta and multiply with this form. So that will give me du that is equal to secant theta tan theta plus secant squared theta multiplied by d theta. So this whole stuff has been represented in this place. This is what we have. So that is basically what I'm going to do. I would actually replace it with a du. And this whole stuff, this actually has been written as u over here. So this is going to give us integral of du divided by u. So that is the same thing as integral 1 over u du. Now we know what integral 1 over u is, right? That is basically going to give us ln u. So we should have ln absolute u plus c. Now since we know u is equal to secant theta plus tan theta, we're actually going to have it substituted into this form. So that should give us ln absolute secant theta plus tan theta. This is going to be a plus c. So this would actually be the answer to the question. So we just have some few more questions to deal with. Now try this one out. If you had this, what is going to be the integral of it? And the first thing I'm going to do, I would actually make this to be a u. But that is not actually supposed to be the total form. Now this could be rewritten as this. So I have cosine x all raised to the power of 5. So I can make cosine x as of u. So let u be equal to cos x. So du should be negative sine x dx. Now you know that sine x dx, that is the same thing we have here, right? So what I'm going to do, I will just take the negative to the other side. So that should be a negative du. And that is going to be sine x dx. So here we can actually have a complete substitution. So this is going to be u to the 5th. And here we have a multiply by a negative du. Of course, this is actually going to go to the other form. So we should have a negative integral u to the 5th du. Now this should give us negative u to the 5th plus 1 divided by 5 plus 1 plus c. So we should have negative u to the 6th divided by 6 plus c. Of course, we know u is equal to cosine theta. Well, this should be cosine x, so I just need to write cosine x. And this should all raise to the power of 6. And finally, this should be negative 1 over 6 cosine to the 6th of x plus c. So that is the answer to that question. Now here is the last question. Evaluate the integral of cosine to the 3rd alpha d alpha. How can you actually solve this question? Now, first off, you need to know some trigonometric identities. If you have secant, well, this should not be secant, I should actually say sine. So if you had sine squared alpha plus cosine squared alpha, that is actually equal to 1. Now, I can make sine squared alpha to be 1 minus cosine squared alpha, or I could make cosine squared alpha to be 1 minus sine squared alpha, right? So that is what I'm going to use in this question. So first off, I will split this, and this changes to cos squared alpha multiplied by cos alpha d alpha. Now we know that cos squared alpha, that is the same thing as this stuff. So this changes to 1 minus sine squared alpha. And this is multiplied by cos alpha d alpha. Now here I'm gonna make u to actually be sine x, right? Well, this should be sine alpha. So let u be equal to sine alpha. And this is actually reasonable, because if I differentiated this, I would actually have cos alpha d alpha, which is exactly what we have here. So that works. So this is going to be integral 1 minus, now we know that this should be u squared because we have u to be sine x. So sine squared x should be u squared. And over here, we just have du, right? So we need to work this. This obviously will become integral 1 du minus integral u squared du, right? So this is going to give us u minus u to the 3rd over 3 and plus c. So since we know u is sine alpha, we just need to change that final layer to the final answer. That is going to be sine x, or sine alpha rather. Here we're going to have sine to the 3rd alpha divided by 3 plus c. So that is the final answer to the question.